Ever wondered how to find the line of best fit in a scatter plot using technology? Well, you're in the right place. In our mathematical journey today, we'll be exploring the concept of the line of best fit, a critical tool in data analysis that helps us predict future trends based on existing data. This line is represented by the equation y equals a plus bx, where x is our explanatory variable and y is our response variable. But what are these a and b we're talking about? Well, they are coefficients, each playing a unique role in shaping our line of best fit. The b represents the slope of our line, indicating how much y changes for each unit change in x. And a, that's our y-intercept, the point where our line crosses the y-axis when x is 0. Now that we understand the basics, let's dive into the process of determining these coefficients using technology. So, what exactly are these coefficients a and b? Glad you're curious? Let's delve into it. In the formula y equals a plus b times x, or y equals sine a plus bx for short, a and b are the keys that unlock the mystery of the line of best fit. When we're using this formula, x is our explanatory variable. It's the factor we think might be influencing something else, which is represented by y, our response variable. Now let's shine the spotlight on coefficient a. In the world of mathematics, a is known as the y-intercept. It's the point where our line of best fit crosses the y-axis. Imagine for a moment a graph with an x and y axis. If you were to follow the line of best fit to where it intersects with the y-axis, the value at this point is your a coefficient. Moving on to b, the star of the show, the slope of the line. The b coefficient represents the rate at which y changes for every unit change in x. When b is positive as x increases, so does y. In contrast, if b is negative, y decreases as x increases. Why are these coefficients important, you ask? Well, they give us the power to predict and understand relationships between variables. The y-intercept a provides a starting point, a baseline if you will, while b, the slope, shows us the direction and the intensity of the relationship between x and y. In other words, a tells us where we start, and b shows us where we're going. To illustrate, let's consider this. Suppose we're analyzing the relationship between hours studied and test scores. A would represent the score you'd expect if no hours were studied. Let's hope no one's starting there. And B would show how much the score changes with each additional hour of study. With a solid understanding of these coefficients, it's time to learn how to calculate them using technology. Stay tuned. Now, how do we find the value of B using technology? I hear you ask. Well, it's not as daunting as it might sound. We'll just be using our handy formula B equals R times psi over Sx. In this formula, R represents the correlation coefficient, Sy is the standard deviation of y, and Sx is the standard deviation of x. Imagine we're dealing with a data set where x is the number of hours studied and y is the test score. We've already calculated our standard deviations and found that Si is 4 and Sx is 2. We've also determined the correlation coefficient, R, to be 0.75. So, let's plug these into our formula. Our B value is then calculated as R times psi over x. That's 0.75 times 4 over 2. Doing the maths, we find that B equals 1.5. But wait, you might say, what does this B value mean? Excellent question. In our example, the value of B 1.5 means that for every additional hour studied, we can expect the test score to increase by 1.5. Now, let's try this with technology. There are many calculators and software programs available that can do these calculations for us. For instance, in a spreadsheet software like Excel, you can use the CORREL function to calculate the correlation coefficient and the STDVP function to find the standard deviations. Once you have these values, you just multiply and divide as we did earlier to find B. It's important to remember that B is only part of the overall equation for our line of best fit. It tells us about the relationship between x and y, but it doesn't give us the full picture. That's where our next coefficient, A, comes in. Once you've mastered finding B, you're halfway there. Next up, let's tackle coefficient A. And remember, practice makes perfect, so don't be afraid to play around with different data sets and calculations. You're doing great. All right, now let's figure out how to calculate coefficient A. Having determined the value of coefficient B, we can now use it to find out the value of coefficient A. Remember, in our equation y equals a plus b times x, A is the y-intercept. That is, the point where our line of best fit crosses the y-axis. To calculate A, we have a simple formula, A equals y bar minus b times x bar. Here, y bar represents the mean or average of all the y values in our dataset, and x bar is the mean of all the x values. Let's illustrate this with an example. Suppose we have already calculated the value of b from a set of data, and it is 2. Our dataset consists of the following pairs of x and y: 3 and 5, 4 and 7, 5 and 9. The mean of the y values, or y bar, is 7, and the mean of the x values, or x bar, is 4. Plugging these values into our formula, we get a equals 7 minus 2 times 4. That simplifies to 7 minus 8, giving us a -1. So, in this case, the line of best fit would cross the y-axis at -1. You can use a calculator or software to do these calculations, but it's quite straightforward to do by hand as well. This method of calculating A is very effective and can be used regardless of the size of your dataset. Remember, the coefficients A and B give us a line that best fits our data. It's an approximation, a prediction, a guess if you will, but a very educated one, based on the actual data we have. The line can help us predict future data points, or just give us an understanding of the relationship between our variables. And there you have it. You now know how to calculate both coefficients A and B. Understanding these calculations and their significance can help you make sense of data, and that's a skill that's useful in many areas of life. So, keep practicing and keep exploring the world of mathematics. You're doing great. So, we've calculated our coefficients, but what do they mean? Now that we've navigated the waters of calculation, let's delve into the world of interpretation and see how these coefficients make sense in real-world scenarios. Firstly, the coefficient A. This is our y-intercept, the starting point of our line of best fit when x equals 0. In simpler terms, it's where our line intersects the y-axis. It's our baseline value, the response variable's value when the explanatory variable is absent or 0. For instance, if we're predicting a student's final math score based on hours of study, A could represent the score they might get if they didn't study at all. Now, let's talk about B, the slope of our line. This coefficient tells us the rate of change in y for each unit increase in AX. It's like a mathematical interpretation of cause and effect. If B is positive, it means as AX increases, so does y. If B is negative, y decreases as X increases. In our student's example, B would represent how much the math score increases for each additional hour of study. These coefficients can be powerfully insightful in various scenarios. In business, they can help understand how changes in cost affect profit, or how advertising spend influences sales. In healthcare, we can study how changes in diet or medication dosage impact a patient's health. In environmental studies, they can illustrate how rising temperatures affect sea levels. Yet, it's crucial to remember that correlation doesn't always mean causation. Just because two variables move together, it doesn't always mean one is causing the other to change. It's also important to consider other factors that could be influencing the relationship. In conclusion, the coefficients A and B are more than just numbers. They're a gateway into understanding relationships, predicting outcomes, and making informed decisions. Remember, understanding your data is just as important as calculating it. Let's quickly revisit what we've covered today. We delved into the realm of coefficients A and B, the key components of the line of best fit equation, y equals a plus b times x. We discovered that x represents our explanatory variable, while y stands as our response variable. We learned how to determine these coefficients using modern technology, and the formulas B equals RR times psi over Sx, and A equals Y minus B times X. We also understood that these calculations aren't just mere number crunching. They hold meaningful interpretations and applications in our data analysis. Remember, coefficients